Let's do the next guest. As this guy to my right just said, shares of GE are they're up. You've seen that this morning. You can see right there, about 3%. The company did beat earnings expectations, the analysts who follow it. It also posted positive free cash flow for its second quarter. And joining us now, first on CNBC, is Larry Culp. He is chairman and CEO of GE. And Larry, always good to have you. Feels like it's been a little while. You know, I wanted to go to the big picture for a second, if I can, because there's a quote from you, and I know this is what you want people to focus on. GE is transforming to a more focused, simpler, and stronger high-tech industrial company. That's what investors certainly want. What can you point to in this quarter that says you're accomplishing that task?
David, Jim, good to be back with you. David, there's a lot in the second quarter results that the GE team posted today that I think speak to the transformation. Orders up 30% year on year. Services, which represent half of our revenue, were up 50% versus a year ago. Revenue's up 7%. Our operating margins expanded 1,000 basis points organically. And as you noted, we have positive free cash flow, which was something we weren't necessarily expecting just a few months ago. We look at that on balance. I think the underlying improvements in the business, and I would argue we've got improvements in every one of our businesses, really help drive that performance. And in turn, as we think about the rest of the year, you also see us this morning taking up our free cash flow guide to $3.5 to $5 billion in terms of free cash potential this year. So there's a lot that we're proud of. I think the GE team had a good second quarter, a good first half, but a lot more to do with these businesses, no question.
Yeah, well, aviation certainly is one where people had been concerned for obvious reasons. You say, on the call, you said this as well, that you're confident in your path to recovery in aviation. What gives you that confidence, Larry?
David, what we look at every morning are departures around the world by region, by engine platform. And what we've seen for several months here is the U.S. Recovering. You heard from all of our airline CEO customers just last week relative to those trends. We see Europe slowly, gradually coming back here of late as well. China is just off single digits from where they were in 2019. So the key markets for us around the world are improving. We see that knock-on effect in our shop visit activity, which is really the core work that we do in our aviation services business. We saw shop visits improve sequentially in the second quarter compared to the first, and we think we'll see continued sequential improvement into the back half. Clearly, lots of things that we all have our eyes on, including the Delta variant. But that said, it looks like the leisure traveler is back, and business travelers are not that far behind, hopefully. I think on balance, that's what gives us the optimism and the confidence about our aviation business.
Oh, Larry, it's Jim. When you talk about the business traveler coming back, I'm not getting that. Is that, and I thought the quarter was good. I just want to follow up on what you said. I see that the regular traveler is really on fire, though, and 2019 numbers are being beat. And what that seems to generate for you is a lot of cash. Can you talk about cash?
Well, we talk a lot about cash today at GE, rest assured. Clearly, the aviation business that generated more than $4 billion of free cash in 2019 is a key part of our cash story. That's largely in our services business. And as we see those departures accelerate, in turn, our shop visits improve, that gives us an opportunity to increase our cash billings to our customers. It's really that pay by the drink, that power by the hour model. Obviously, it hurt us last year when the planes were not in the air. But as the planes fly, that's good for us. But it's not the only way in which we are driving cash in aviation and, frankly, across the company. We talked a good bit on the call this morning about the lean-driven working capital improvements we see. We're trying to be more efficient, more disciplined with our capital expenditures as well. So there are a lot of small things whose cumulative effect, Jim, really helps us drive the cash performance you see in the second quarter, the increase in the guide for the back half, and more importantly, that high single-digit free cash margin we talk about being our ambition over the next several years.
What the world needs now is people. People who see things just a little bit differently, who go out of their way to find a new perspective and a new way forward. People who make faraway places feel closer, with flight that's more fuel efficient. Who put the focus of healthcare where it belongs, on making patients healthier. People who see how more sustainable energy can power daily life while powering progress. Because seeing a smarter, healthier, cleaner world isn't something that's far in the future. It's something we're building now. GE, building a world that works.
Today we released GE's sustainability report, and we used the theme that actions speak louder than words. GE has changed a lot over its 129-year history. The one thing that stayed the same is a higher purpose that drives our passion for sustainability. From our founder, Thomas Alva Edison, to the Haliade-X, the world's most powerful offshore wind turbines built today, our pioneering technologies aim to positively transform the world and improve the lives of people everywhere. First, we want to reduce the emissions associated with the generation of energy, but we also want to make energy more accessible to the billion people in the world who lack reliable energy to turn on their lights, to access healthcare, to be able to go to school. When we think of breakthrough technologies in the energy sector, we think of carbon capture sequestration and decarbonizing gas turbines longer term. We also look to hydrogen as a fuel. Already today, our turbines can run on a mix of gas and hydrogen. We're looking to increase the utilization of hydrogen, as well as look at green hydrogen production. We're investing in small modular nuclear reactors, the next generation of nuclear technology. We're really proud of the investments we're making to make sure we're looking around the corner at solving not only today's sustainability challenges, but helping our customers solve tomorrow's challenges as well. When we think about sustainability, it's critical and essential that everybody in the world have access to strong health care, to the same opportunities to have diagnosis and treatment for any kind of conditions. So one of the things we're very proud about as GE is the way we innovate our technology to make large machines portable, to make them accessible to people in all kinds of geographic conditions, all kinds of socioeconomic conditions, and to make sure we're reaching half of the world's population which lacks access to reliable healthcare today. Finally, we're focused on the future of smarter and more efficient flight, knowing that we need to keep people connected, but have to do so in increasingly sustainable ways. So we've announced recently our commitment to develop open rotor technology, building on our legacy of innovating technology for jet engines to increasingly reduce emissions, while at the same time looking decades ahead at what are those breakthrough technologies we need. Moving forward, we plan to approach sustainability like we run our businesses, with an operational rigor, using lean principles to continuously improve and make sure we're eliminating waste. Lean and sustainability go hand in glove. Lean is all about continuous improvement, driving more efficiency, making sure we're using our resources better and more efficiently. We constantly want to improve our processes, not only to be part of the solution, but to make sure we're making people safer when they come to work with GE, that we're addressing human rights across our whole supply chain, that we're looking to be environmental stewards of our resources. We know today the stakes are high. In 2020, we announced we will be carbon neutral in our own operations by 2030. This is a significant commitment for a global industrial company, and we're excited to achieve it. In addition, we're announcing an ambition to be a net zero company by 2050, taking into account the emissions from our sold products. These are frequently referred to as Scope 3 emissions. With our commitment to innovation, we look forward to being a key partner with our customers in providing the tools they need to realize their own emission reduction goals. I feel really privileged to be part of GE, one of 174,000 employees in 170 countries working together, united towards one purpose. That's the thing that kind of leaves me in awe, is our global reach and the sophistication of one company united in this commitment to sustainability is something that's a source of pride for all of us.
Part of the reason that I came to work on nuclear energy was that I wanted to make sure that what I was working on really empowered people, and producing carbon-free energy does just that. It gives us the power to do the things we want to do every day.
Whether it's the goals of the Paris Agreement or individual countries, provinces or states, or even private companies, everybody is getting carbon goals out there. And our team has been able to model out what it would take to get you to deep decarbonization. You can certainly go quite a long way with renewables, wind and solar, but you can't get across the finish line. You've got to be able to bring dispatchable nuclear energy, and small modular reactors in the BWR X300 fits that bill perfectly.
Everybody in my family is an engineer, and my dad worked in the nuclear field, and I've always worked at a nuclear power plant. So when I'm talking to other parents sitting on the bleachers watching my son play soccer, and they say, "Where do you work?" "Well, I work at a nuclear power plant." "Oh my God, you know, what's that about?" Great opportunity to say, it's not scary. This is going to help the environment. You have constant supply of energy all the time. And I can make sure if the sun isn't shining, I can still have power to do the things that I need to do. And it's carbon free.
My name is Christer Dahlgren. I'm the principal designer of the BWR X300. We're basically taking the known building pieces from the nuclear industry today, and we're applying them, let's say, like a Lego kit. So the pieces themselves already exist. They're basically building blocks that have been pre-designed. You're not building them in the field. They're coming to the site already built and pre-tested. So nothing in this plant is really brand new for this application. The application is new, but the component that we're using is not new.
Small modular reactors. The word modular refers in large part to the construction technique and the approach that these are more of an installation as opposed to a construction project. So trying to avoid what we have seen historically, where you have long drawn out construction periods, during which time the owner is investing in all of that capital to build that particular plant. With a small modular reactor, you have not only an overall smaller cost, the reactor, in this case the SMR, is up online and producing electricity much faster.
We're leveraging the fuel that we already sell to plants all over the world.
Fuel, in my opinion, is the most important enabler to bringing a new reactor technology to market very rapidly. I'm sitting in the control room of our fuel fabrication facility. The fuel that's going to be used in the BWR X300 is called GNF2 fuel. It has operated in 75% of the boiling water reactor fleet globally. We've manufactured over 20,000 of these fuel assemblies in this facility. The reason that's important is based on our experience, and we've been designing and licensing new fuel for decades. It takes 10 years to both design and license and deploy a new fuel type. It took GNF2 10 years. It took our most recent design 10 years. And so if we're serious about meeting decarbonization goals, then we have to start deploying new reactor technology quickly. And the way to do that is deploying technology that utilizes proven and existing fuel types.
So this is a model of one of our nuclear fuel bundles. Inside each rod, you can see this cutaway has uranium fuel pellets about the size of your little finger. Each pellet has the equivalent energy of 1 ton of coal. So if you think about the energy in a given fuel bundle and a nuclear reactor, the amount of energy is just tremendous.
Exelon operates 21 reactors. 14 of those reactors are General Electric reactors. So in addition to selling the original plant, over the years, GE provides also fuels and services. So that reliability and comfort associated with that supply chain is certainly a very critical factor.
Estonia is part of European Union, which has adopted legally binding policy goal of achieving carbon neutrality. Small modular reactors, I believe, will be most important part of the solution, especially in northern European and American settings where solar and hydropower is limited.
In case of Poland, we have to decommission about 200 coal-fired boilers. So we're talking about 40 gigawatts of energy, which have to be replaced with something. And we would like to replace these with the zero-emission energy.
Over 60% of electricity generation in the province of Ontario comes from nuclear. My family home is in Pickering, which is honestly a stone's throw from the Pickering nuclear plant. And I grew up with nuclear power, so much so that when I was at university, my first university summer job was at the Pickering nuclear power plant. And I share that because we're comfortable with it. We're good at it. And this is an opportunity for us to build on it and be a global leader in this technology that will be so vital, not just for Canada's energy transition goals, but for the globe.
This design is really an ideal balance of breakthrough innovation coupled with proven technology. We have high confidence that on day one it's going to operate at above a 90% capacity factor.
I actually have gone back to Princeton to talk to students about the option of being part of the nuclear energy field. And what I tell them is that it's a really exciting place to be because we are developing new technologies, we're developing new small modular reactors, we're going to be deploying them over the next few years, and it's really going to make an impact on the world. In the future, it's going to power our cars, it's going to power the work that we do, all of the great AI and computers that are going to be invented, they all need that electricity. So this is a great way to have a big impact.
So with these very challenging decarbonization goals, whether it's 2050 or 2035, it's an imperative that we start now. And we're able to do that. We have our design in a position such that we can bring this on the grid by 2028.
Okay, give me some facts about Germany.
All right, Germany has a lot of sausage, a lot of beer. And I hear that they're helping power 1 million homes using offshore wind farms. Hi.
Hey, Allie. I'm Patrick.
Allie, hi.
Great to meet you.
Hello.
Adam, thank you for coming. Yes.
This is what we came to see, right?
This is it. This monster will help bring power to about 1 million German households with clean, renewable energy.
So this gargantuan yellow thing is itself a device?
Yep, that's it. We're gonna show you inside. Let's go.
Big yellow mystery.
So this is Sabila, our technical expert who's going to be helping us guide through the offshore converter station. And where we are right now is the gas-insulated switchgear room. This is the power's first stop. So if anything goes wrong, this is an area where we can switch off the power.
And what is a gas-insulated switchgear?
Normally, when you have an outside field, you have a lot of space in order to make sure that there's enough clearance. We have here not enough space available, so that's why we have to have the gas-insulated switchgear.
So the gas insulation allows you to fit more in a smaller area. Okay.
From here, the power goes up to the transformer room to get juiced up. From there, it goes to a reactor hall where the power is smoothed out. From there, it goes up to the valve hall. That's where the AC is converted into DC for the trip back to land. So it's easier to see than it is to talk about. So let's go have a look.
Okay.
Easy peasy process.
Yeah.
Really simple.
Yep.
Oh, man. This is huge.
So this is one of 2 transformers that's on the station, and this is where the power is charged up for the road back to the land.
Wow. I have so many questions, but I'm going to start with, what do you mean charged up?
So think of the 2 cables that are running back to land as a highway, a power highway that we're creating. That highway can only take so many cars.
By cars, you mean electrons?
The current, correct, that's flowing. And we want every one of those cars filled with energy.
So when you say it gets juiced up, like what numbers are we talking? What does it come in as? What does it go out as?
When the energy is generated by the wind turbines, it's at about 33 kilovolts. And by the time it reaches this station right here at the transformer, it gets increased to 350 kilovolts for that trip back to land.
The increased voltage, that makes it more efficient to travel?
That's correct. So this is the reactor hall. Here, the energy comes after it's been increased up to 350 kilovolts. Yeah. And it comes into this room to be smoothed.
What is the benefit of having smooth power?
Yeah. The grid likes stability. Because it's interconnected, what happens in one section can dramatically affect another section. So whenever we send power along, we want it as smooth as possible.
So it's coming in from there, going to these aliens where smoothing happens somehow, and then leaving to somewhere else.
Yes.
To the valve hall where the magic happens. Let's go check it out.
Okay.
Yeah, cool.
Come on in. So this is the valve hall. This is where the AC is actually converted into DC. You want to have a look?
Yeah.
All right, we got to put on some booties.
Got marshmallow feet.
As you know, there are 2 ways electricity can flow. There's AC, or alternating current, which travels in a wave. That's great for powering your lights and appliances at home. Or there's DC, or direct current, which travels in a straight line, making it much better for traveling long distances, like from a remote offshore wind farm.
Does that give you more advantages in terms of less energy loss?
Exactly. We get more real power out at the other end, which is what we want.
And eventually, there will be a James Bond movie filmed in this room, right?
Correct.
The villain's gonna be wearing marshmallow shoes.
Yes. Okay, it's unbelievable, but obviously it's not gonna live here. Where is this thing gonna end up?
That's where we're going next.
Excellent.
Very cool.
We are actually on our way out to where the substation is going to be installed.
How long does it take one of the stations that we saw being built to get out?
Well, it'll take about 5 to 8 days to get out to its location 50 miles off the coast. It's on a custom-designed barge that tugboats will tug around Denmark.
Oh, look at that. Holy cow.
That is huge.
Really didn't expect it to be that large.
I know.
That's incredible.
The Darwin Gamma will be 15 stories high, roughly the length of an American football field. They're huge.
Yeah. If this station were manned, this would be a hell of a commute.
Traffic's decent though.
So these cables come onto shore. They've got to be converted from DC back into AC. I kind of want to see what happens next.
Yeah, me too.
All right, that's where we're off to next.
Awesome. Coolest part of this job is that I'm looking around at this stuff and now I have names for it. I understand it.
I know. Not enough to start taking anything apart though.
No. Hello.
Hey,
welcome.
Hi.
All right, where are we?
Well, this is the last stop on our power highway. So the power has now traveled as DC 50 miles underwater and 50 miles underground to this point right here. And in this building, it's converted from DC back to AC.
So it started out as AC. You converted it to DC. Took a lot of time. Now you're converting it back to AC. Why are you doing that?
Because the German grid is set up that way that it transmits the power via AC.
Okay, so once it gets converted back to AC, then what happens?
2 air-insulated switchgears, one here and one here. And in the middle there is this huge transformer, actually it's 2, which are stepping up the energy from 350 kV to 380 kV. They are the largest ones which GE ever built.
Can we see them?
Yes.
All
Let's
right.
go. Let's go. Please.
So these are the transformers?
Yes.
Amazing. And then they're going this way.
Yes.
Look at that.
Okay, so our journey's ending this way, right?
Yes.
And that's where the power goes to happy Germans cooking in microwave ovens and watching television.
Yes.
Exactly. What started 100 miles offshore, the power has now been converted twice and is now ready to go on to light up houses and hospitals and businesses in Germany.
With like up to 1 million people having no idea that this all originated on a wind farm in the middle of the ocean.
Amazing.
Hey, I'm Allie.
Hey, Allie, I'm Gordy. Nice to meet you.
This place is huge. What is happening?
Yeah, this is essentially the Burning Man for private pilots.
Okay, so all the plane nerds are here.
Absolutely.
Right?
People everywhere, yep.
I can't wait to see some stuff. Let's go look.
Yeah, let's do that.
Okay.
Cool, go this way.
Oscar Tower, Sky Class E2800, holding it out.
This is crazy. I have never seen anything
That's right.
of this scope. I mean, how many planes are here at a time?
So there's 10,000 planes here, spanning everything from classic planes to true experimental aircraft to more traditional aircraft. There's an F-86, that's like a Korean War era jet, it has GE engines in it.
Oh, wow. Now, what is this?
So over here on the left, we have a B-29 Superfortress. This was actually used in World War II.
What aspects mechanically are GE made on this?
Yeah, so we made the turbo superchargers. It's a small piece of machinery that sits in front of the reciprocating engines, and it pressurizes the air so that they could fly very fast at high altitude to get over target, do what they need to do, and then get back to safety. But really, what it wanted to be able to do is fly high enough to be above all the fighters. So this was really the first turbo machinery that GE built, and after this, we then started developing whole aircraft engines. So this is really where we kind of all got our start. So this airplane right here coming up on the right, this is a Thrush 510G, and it has an H80 engine in it. This is one of the engines that we make.
Okay.
And we actually have one in the chalet.
Oh, you do?
Yep. So this is the H80. This is an engine that was originally designed back in the 1960s. But we've just continuously improved it over the last 50 plus years. It just keeps getting better and better and better. And it's really a fantastic engine up to about 850 horsepower.
What came next after this?
So let's go over to the next one, the next link in the chain.
Ooh, what is this?
So this is the T700. This was designed back in the 1980s. You can see it's more complex. It's a more powerful engine than the last one we looked at. This is really used primarily for helicopters like the Apache and the Black Hawk. This is basically state-of-the-art today. Now let's go look at what we're going to do tomorrow.
The future.
The future. Yes. All right, so this is the Advanced Turboprop. And what we've done here is we've taken all of the best technology and learnings from those last two engines, plus everything we've learned on the large commercial engines, and we put it into this.
So what's different about this engine?
Two things that really make this engine different, and that's one, there's extensive use of additive manufacturing.
Oh, okay.
And then the other thing is this has a digital engine control.
What is digital engine control?
The planes that we saw on our ride, basically they all have a hydromechanical control, which means the pilot has to make a decision on everything. So they're independently controlling the propeller, they're controlling the engine.
Right.
So what this does is it simplifies all that into an electronic control, and that frees up the pilot to think about other things, so they can really fly the aircraft instead of flying the engine.
Is this GE's first turboprop engine with additive manufacturing?
It's really the world's first engine with extensive use of additive. Basically, we took 855 parts that would normally exist if we did it conventionally, and condensed that down to just 12 parts. You know, parts that are large, complex assemblies that have to have people assemble those things together, and those parts add weight, they wear out, and they create leakage pads, which robs the performance and efficiency of the engine. So the end result that you have here is a combination of technologies that we've really never used on small engines before.
What do these parts look like?
Okay, so we have some over in the cabinet over here if you want to go take a look.
Yeah, let me see.
So this is a fuel heater. So fuel goes in here, and engine oil goes in here, and heats the fuel.
Now this is one part?
This is one part, that's right.
How many parts would you usually
So normally this would be about 300.
300 parts.
That's right. Yep.
Is it lightweight?
It is, so it's about half the weight it would normally be.
So this is one part now.
One part.
That is such a victory.
Runway 36 cleared for takeoff.
Well, this was an awesome, cool day.
Yeah, thanks for coming. It was really a great day. I hope you enjoyed it.
So I guess there's like nowhere to go but up.